Hello everyone, Anirudh here. I am a student of Indian Institute of Technology, Kanpur, a third year undergraduate in the Department of Computer Science and Engineering at Total Speed course, and I am a resident of SIN. Today I'll be dealing with Introduction to Three-Dimensional Geometry. That's chapter 11 of class 11 maths. For all those of you who have not seen the maths textbook, right? You have a quote from E.D. Bill that maths is both the queen and the hamlet of all sciences, right? I mean, a very interesting quote because frankly speaking, no science can exist without maths because maths is the underlying calculation for all sciences, right? But yeah, that's neither here nor there. So in this chapter, what we're going to deal with is the representation of space itself, right? So in the real world, how exactly do you deal with heights? How do you deal with lengths? How do you deal with a width or some kind of breadth-wise calculation? How do you do that? It's by guesstimating what space is, right? And you do that by using by using the concepts of three-dimensional geometry, because we live in three-dimensional space, and you can maybe consider it four-dimensional for also consider the axis of time, but again, neither here nor there. So what we deal with is the mathematical representation of what space is and how you do that in geometrical terms, right? So the first thing you see in this chapter is going to be the representation of the coordinates, that is the coordinate axes and the coordinate points, right? And for three-dimensional space, you're going to deal with a set of three things, right? Three terms, which together actually represent the position of a point in space, right? With respect to an origin. Right? You can't forget this because without this origin, this point is meaningless, because this is going to be the distance from the origin along each of the three axes that you define, right? And by convention, these three axes are going to be perpendicular to each other, and you're going to call them x dash, y dash, z dash, or x dash, y dash, z dash, because the origin is going to be the conjunction of all three axes, right? And they're going to be mutually perpendicular to each other. So the z-axis is going to be perpendicular to the y-axis, y is going to be perpendicular to x is going to be perpendicular to z, and it's going to be repeat with the other three sets also, right? So we and when you take two coordinate axes together, you get a plane, right? A plane is going to be defined by two axes that you're going to I think you're going to learn it in your next year in actual three-dimensional geometry, where you're going to deal with the representation of plane by two lines, plane and a line and a point, etc., right? So these things are two axes together is going to define a plane, and you have three such planes. That is the XY plane, that's defined by the x-axis and the y-axis. You're going to have the YZ plane, that's going to be defined by the y-axis and the z-axis. That's going to be parallel to my computer screen. The XY is going to be horizontal, basically, and the XZ, which is defined by the x, is going to be defined by the x and the z-axis, and is going to go through your computer screen, right, perpendicular to it, right? So these are the three planes that are going to have. That's called the x, y, y, z, and the zx plane, based on the two axes that make up the plane, right? Now, and then you have the point O, that is called the origin of the coordinate system. That is going to divide a whole space into 8 octants, right? This is going to be the first octant, right? You have 8 octants basically, and you have a numbering system as to which octant is 1, which octant is 8, and which is 5, right? You have a numbering system, right? And now you deal with the representation of a point, right? So consider a coordinate system, right? Consider a coordinate system kind of like this, right? I'm going to say this is the origin. This is going to be the x-axis. This is going to be the y-axis, and this, right? I just did it off quickly. This is going to be my z-axis, right? Wait a minute. I'm sorry for that. Wrong picture. If this is x, this is y, then this is going to be my z-axis, right? I'll just zoom out a bit so that you can see the whole screen, right? Assume that the z-axis is going to come just outside the plane of paper or the plane of a computer screen, all right? Now, since this is going to be the origin, this point is going to have the coordinates 0, 0, 0 with respect to the origin, right? Because it is distance 0 from the origin, basically, right? Then for any point, say P over here, right? let this P be a point over here. It is not lying on the XY plane. All right. It's going to be somewhere projected outwards, right? Which I can't represent because this is a two-dimensional plane of paper. All right. Now, let this have something like this. This is the vertical on the X. This is going to be the vertical from P onto the Y-axis. And basically, let this line extend back, right? Something like this. This be the perpendicular of the Z-axis. All right. So the X coordinate, let this be A. The Y coordinate, let this be B. And the Z coordinate, let this be C. Right? So you represent this point P as A, B, C, as you have learned in normal two-dimensional geometry, except that you have another axis to take care of over here. Right? So you have given a point P in space, we draw a perpendicular PM on the XY plane with M as the foot of this perpendicular. From the point M, we draw a perpendicular ML to the X-axis, meeting it at L. Right? I've drawn this this way because I've just directly taken the perpendiculars from P to Y, P to X, and P to Z. Right? You can also do it this way, where you drop a perpendicular to the XY plane, and then you draw its, the X, the perpendicular to the X and the perpendicular to the Y from this point. Right? They give you the same answer. It's going to give you the same answer. Right? That is you can prove it elementally by geometry. That's not an issue. All right. Then X, Y, Z are called the ABC is here over here is called the X, Y, and Z coordinates of this point. Right? And these three together, they make up the representation of this point P in space. All right. Now you have, okay, fine. This paragraph basically deals with the whole this whole system by drawing planes parallel to the XZ, YZ, and the XY through this point P, so that the plane meets this axis at exactly one point. That is going to be the X coordinate. It means this line at one point. That's going to be the Y coordinate. And this line, the plane meets this line at one point. That's going to be the this is going to be the Y coordinate. This is going to be the Z coordinate, basically. All right, you can do it by planes. You can do it by lines. You can do it by projection and then perpendicular lines, whatever. Any system you follow is going to give you the same answer, basically, right? And if it gives you a different answer, that means you have done something. You have done a mistake, right? Finally, you have this table which deals with the octant system. Right? You have the octant number and the position of the three coordinates. All right. So given some space, wait, let me just erase this. Given a coordinate system like this, right? Origin, I'll extend everything on both sides. All right. Let this be X, let this be Y, let this be Z. Right? This is going to be minus Z, this is going to be minus X, this is going to be minus Y. All right. So given such kind of a system, right, you will basically have something like should I draw keyboard? I think that'll help, right? Right. And then similarly downwards, right? Something of the sort, right? I'll not draw the keyboard down, but you get my meaning, right? Something of the sort, right? Which extends on both sides everywhere, right? So this cuboid, right, which deals with the plus X, plus Y, and the plus Z axis, right? This is going to be your first octant, right? The cuboid that is going to deal with minus X, but plus Y and plus Z, that is going to be over here. This is going to be your second octant, right? The cuboid that is going to deal with minus X, minus Y, but plus Z, that is going to be the third octant, right? And the fourth octant is going to be plus X, but minus Y and plus Z, right? Similarly over here, the cuboid that deals with X plus Y and minus Z is going to be your fifth octant. The cuboid that deals with minus X plus Y and minus Z is going to be your sixth octant. The cuboid that deals with minus X minus Y minus Z, that is going to be the seventh octant. That's going to be down below. And the eighth octant is going to be X minus Z and minus Y. That's going to be down below. All right. So these are going to be the 8 octants that are going to define, right? And it's going to be defined almost exactly like how you define your Cartesian plane, right? Where in the Cartesian plane you had X and Y. This is going to be 1. This is going to be 2. All right? This is going to be 3 and this is going to be 4. The same way you're going to project this out, right? So you have 1, 2, 3, 4 over here, exactly the same way as this. And then in the back, corresponding to 1, you have 5, corresponding to 2, you have 6, corresponding to 3, you have 7, and 4, you have 8, right? Plus Z is going to be 1, 2, 3, 4, minus Z is going to be 5, 6, 7, 8. That's basically the octant system that's defined, right? And with that, we jump to exercise 11.1. All right. So for exercise 11, before exercise 11.1, you have these two examples where you have if point P is 2, 4, 5, find the coordinates of F and find the octant and is a point these apply, right? These are just exercises to test the understanding that you have of the octant system. So if you want to do it, you can. If you don't want to do it and you're very comfortable with the octant system, then you need not, right? Now exercise 11.1. A point is on the x-axis. What is y and z coordinates, right? So for question number 1, right? Let me draw the axes because that's going to be useful in explaining, right? Let this be the z, let this be x, let this be y. All right. You have a point that lies on the x-axis, right? P is on the x-axis, right? Now, consider the fact that the x is going to be perpendicular to z, the x is perpendicular to y, right? If you drop a perpendicular from this point to the z-axis, it is going to lie along the x-axis and is going to fall on the origin, right? So basically, the coordinates of this foot of the perpendicular is going to be 0. Same for y, right? So this point P on the x-axis is going to be defined, is going to be written as a, 0, 0, right? Therefore, the y coordinate is 0, z coordinate is 0, right? That is the required answer, right? You can basically think on it for a little while, and a point on z axis is going to have y and x coordinates 0. A point is in the xz plane. What can you say about its y coordinate? Again, the point is in the xz plane, right? It's going to be somewhere over here. This point. Let this be Q, right? This is for the first question. This is for the second question. But right, I'm going to use the same figure because I'm too lazy to keep drawing figures again and again, right? Now think on the fact that one way that you can measure the coordinates of this point is going to be to draw a perpendicular from this to one of these coordinate planes and figure the two, figure two these coordinates and draw a perpendicular from here to y-axis. All right. Since it is on the xz plane, you will have a defined perpendicular over here. You will have a defined perpendicular over here. No issues because it lies on this plane. But the perpendicular to y, if you remember, is that the y-axis is going to be exactly perpendicular to the xz plane. All right, because it directly comes out of this plane and it is perpendicular to the x and the z-axis. So it's perpendicular to this plane itself, right? Therefore, if you drop a perpendicular from this point Q, which is on this xz plane to y-axis, it is going to meet exactly at the origin. All right, and this is also going to be perpendicular, right? Therefore, since it meets at the origin, this Q is going to have some B, 0, C as its coordinates because it meets the y-axis exactly at the origin. So the y coordinate is going to be 0, right? Therefore, for the second question, the y coordinate is 0 if it lies on the xz plane. This extends to the other two planes also. If your point is on the xy plane, its z coordinate is 0. If your point is on the yz plane, the x coordinate is 0. All right. That is the general statement, and that's supported by geometry. Or if you want, you can just draw this kind of figure out where the perpendicular is going to intersect, and find out the coordinates of that point. With that, you get the y. With that, you get the y coordinate or the z coordinate or the x coordinate respectively, according to which axis you draw the perpendicular. All right. Question number 3. In the octant set is the following points slide. 1, 2, 3. Right. Remember the octant system. 1, 2, 3 is going to lie in the first octant. 4 minus 2, 3 is going to lie in the, wait a minute, I'll just look at this figure, right? You have plus x minus 5, that is going to be the fourth octant, right? Your point 4 minus 2 minus 5 is going to lie in the 8th quadrant octant, right? Because this is minus z and this corresponds to the 4th quadrant in the Cartesian plane, right? This XY pair is going to correspond to the fourth quadrant, right? If Z is positive, then it's going to be 4. If Z is negative, it's going to be 4 plus 4, that's 8. Basically, you can remember it that way. All right, just take XY, figure out which quadrant it lies in, then take the Z. If the Z is positive, then the same quadrant is going to be the number of the octant. If Z is negative, add 4, that is going to be the number of the octant. Right? That's a shortcut technique. Right? Then this is 4 minus 2 minus 5. Then you have 4, 2 minus 5. That is going to be lying in the fifth quadrant. Right? Fifth pair is minus 4, 2, minus 5. This is going to be, this is quadrant 2, and since this is minus Z, is going to be quadrant 6. Right? That's the thing. Yeah. Then you have minus 4, 2, 5. That is going to be quadrant 2. Right? Octant 2. I'm sorry. Then you have minus 3, minus 1, 6. That is going to be octant 3. And then you have minus 2, minus 4, minus 7. That is going to be octant number 7. Right? These then you have classified correctly the octants in which the following points lie. Right? Lastly, you have to fill in the blanks. Right? The x and the y axis taken together determine a plane known as the xy plane. Right? Because the plane is given the nomenclature by the two axes that make it. So basically, if you have taken the x and y axis together, then you have the xy plane. Right? Then you have the coordinate points or the coordinates of points in the xy plane are of the form. As I've already told you earlier, when we dealt with the second question, you are going to have points of the form x, y, 0. All right. And finally, the coordinate planes divide the space into dash octants. Right? You already know it because you've just done it. Right? You have 8 octants over here. Right? And it's also in the name. Octant is basically 1/8 of a whole. All right. So if you have something called an octant, you are going to have 8 octants of it to make the whole thing up. Right? All right. That finishes exercise 11.1. Right? In 11.2, we are going to deal with the extension of the distance formula in the 3-dimensional space. Right? So for 2 points lying in 3-dimensional space, one over here P, one over here Q, with P of x1, y1, z1, and Q of x2, y2, and z2. The distance d between them is going to basically consider this to be the origin. All right. So the distance d between them is basically represented as d is equal to square root of this is what x1 minus x2 the whole square plus y1 minus y2 the whole square plus z1 minus z2 the whole square. Right? Then you have the proof of the whole distance formula thing, which I'm not interested in. You can just read it at your own pace. Right? It's just a basic application of your Pythagorean theorem. And then you're going to get the distance between 2 points, blah, blah, blah. Right? There's nothing else over here. Look at some of these examples, right? Like example 6, this is going to be pretty interesting. Right? But yeah, it's also pretty easy. So you don't need to spend much time on it. But just look at them because they give you ideas on how differently questions can be asked. Right? Then you have exercise 11.2, where you are straightforwardly asked the distance between all these 2 points. Right? Find the distance between the following pairs of points. Number 1 is 2, 3, 5 and 4, 3, 1. Right? As my earlier nomenclature, let me name it as P and Q. Right? So, and let the distance BD. Right? D is equal to directly plugging in the values inside the formula. Right? Since this is P, this is going to be x1, x2, x3. This is Q, this is going to be x2, y2, z2. All right? This is x1, y1, z1. If I said x1, x2, x3 before, forgive me. All right? Now, I'm going to directly plug it in the distance formula. That is what? x1 minus x2, y1 minus y2, z1 minus z2, right? You can also write this as x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. Nobody cares because minus 1 the whole square is going to be plus 1, right? x1 minus x2 squared is equal to x2 minus x1 squared. No one cares, right? So your distance d is going to be 2 minus 4, that is minus 2, the whole square, plus it is going to be 3 minus 3 the whole square, that is 0 square, plus it is going to be 5 minus 1 the whole square, that is plus 4 the whole square, right? Which is basically square root of 4 plus 0 plus 16, right? Which is 4 root 5. Wait a minute, this is 2 root 5, 2 root 5, I'm sorry. This is basically 2 root 5 units, right? Question number 2. You have point P, that is minus 3, 7, 2, and point Q, which is 2, 4, minus 1, right? Now your distance D, which is PQ, is going to be square root of x1 minus x2 the whole square. That is going to be minus 3 minus 2, that is minus 5 the whole square, plus 7 minus 4, that is 3 the whole square, plus 2 minus minus 1, that is 2 plus 1, that is 3 again the whole square, right? Which is basically square root of 25 plus 9 plus 9, which is basically square root 43 units, right? Units is an implied unit, so I'm not writing it up, right? I'm just introducing it over here, right? Then you have question number 3, sub part 3, right? Where you are given the point P of minus 1, 3, minus 4, and you are given the point Q of 1, minus 3, and 4, right? Consider the fact that this is going to have the midpoint of the origin, right? So that is an interesting fact over here, right? Where if you feel it difficult, even though it's not difficult, if you feel it difficult to calculate P and Q directly, you can also do it with respect to the origin and then double the distance, you're going to get the distance of P, right? But yeah, that's neither here nor there, right? Your distance D is equal to square root of x1 minus x2, that is minus 2 the whole square, plus y1 minus y2, that is going to be 6 the whole square, plus z1 minus z2, that's going to be minus 8 the whole square, right? Which is basically root of 4 plus 36 plus 64, which is basically square root 104. That is, this is 426, right? So this is basically 2 root 26 over here, 2 root 26 units, right? And finally, the fourth subpart, that is P of 2, minus 1, 3, and Q of minus 2, 1, 3, right? Notice that over here, the z coordinates are the same, right? So basically, you can treat this as a two-dimensional plane where P is 2 minus 1 and Q is minus 2, 1, and you can deal with the two-dimensional distance formula directly, right? Or you can do the three-dimensional distance formula basically, right? It's just a single extra step, right? This is basically 2 minus 2, that is 2 plus 2, that is, wait a minute, this is 4 the whole square, plus this minus 1 minus 1, that is minus 2 the whole square, plus 3 minus 3, that is 0 the whole square, right? Which is basically a square root of 16 plus 4, that is again a root 20, that is 2 root 5. Right? Or you can just remove the 0 directly, say that since these coordinates are the same, you're going to have P and Q on the same plane. So you can directly deal with the distance formula of x and y. That is going to be 2, or this is going to be 4 square plus minus 2 square, that is going to give you root 20, that's 2 root 5. Right? You can do it anyway. No issue. Right? This not only for z, this can also apply if your y-axis or the y coordinates or the x coordinates are going to be the same. Right? For example, in first question, instead of doing the whole 2 minus 4, 3 minus 3, and 5 minus 1 the whole square, I can directly say that since the y coordinate is the same, I can do 2 minus 4 the whole square plus 5 minus 1 the whole square, and I can say that that is going to be the distance. Right? Non-issue. That finishes the first question. Right? Going to the second question. Show that the points minus 2, 3, 5, 1, 2, 3, and 7, 0, minus 1 are collinear. Right? To show that these 3 points are going to be collinear by using the distance formula, what you're going to do is basically say that for these 2 points, so if your point P is going to be minus 2, 3, 5, right? Then your point Q is going to be 1, 2, 3. And your point R is going to be 7, 0, minus 1, right? What you're going to do is you're going to show that PQ plus QR is going to be equal to PR, right? Or this, or your PR plus RQ is going to be PQ, or the other combination, right? Because we don't know which side is going to be the maximum length. So we have to show that any one of these three conditions is going to hold, right? So basically the maximum of everything is going to be over here. The other two, we are going to show that the sum of the other two is going to be equal to the maximum of three sides, right? So that is going to be what we want over here. That is the theory behind the question, right? So to proceed to the question, what we're going to do is we are going to first find PQ. That is basically square root of x1 minus x2 to the whole square. That is minus 3 the whole square, because minus 2 minus 1 is minus 3. Plus y1 minus y2 the whole square, that is going to be 3 minus 2, that is 1 the whole square. Plus z1 minus z2 the whole square, that is 5 minus 3, 2 the whole square, right? That is going to be square root of 9 plus 4 plus 1, that is going to be root 14 units, right? Then you have QR, that is going to be square root of, this is what, 1 minus 7, that is minus 6 the whole square, plus 2 minus 0, that is going to be 2 squared, plus 3 minus minus 1, that is going to be 4 the whole square, right? This is going to be square root of 36 plus 4 plus 16, right? This is root 56, right? Root 56, that is 14 into 4, that is 2 root 14 square units. 2 root 14 units, not square units. All right. Finally, we have PR, which is going to be PR, which is square root of, this is what? Minus 2 minus 7, that's going to be minus 9 squared, plus 3 minus 0, that is going to be 3 squared, plus 5 minus minus 1, that is going to be 6 squared, right? Which is basically square root of 81 plus 9 plus 36, that is going to be 90. This is 126, right? This is going to be square root 126, which is this is 14 times 9, right? And root 9 is 3. So this is basically 3 root 14 units, right? Therefore, you can see that PQ plus QR, right? PQ plus QR is equal to, actually, instead of just writing PQ and QR, I have to write mod of PQ and QR. And because PQ is a line segment, QR is a line segment, PR is a line segment, right? This represents the distance or the length of the line segment. So we have mod PQ plus length of QR is going to be square root 14 plus 2 root 14 units, right? Units, which is basically 3 root 14 units, which is equal to mod PR, right? Therefore, mod PQ plus mod QR is going to be mod PR, right? This implies that PQR are collinear. Therefore, proved, right? Now we go to the third question. Verify the following, that these are the vertices of an isosceles triangle, these are the vertices of a right angle triangle, and these are the vertices of a parallelogram, right? So the first question, you have P of 0, 7, minus 10. You have Q of 1, 6, minus 6. And you have R of 4, 9, minus 6. All right. And you have to verify that these are the vertices of an isosceles triangle. For an isosceles triangle, you have two sides being equal, right? So for a triangle PQR, you can have either this side being equal, or this side being equal, or this and this and this side being equal, right? And you don't have to have the fact that all three sides are equal, or you don't have to have the fact that only specific two sides are equal, right? So basically, you have to find out the three distances again. Your mod PQ is going to be square root of 0 minus 1, that is minus 1 the whole square, plus 7 minus 6, that is 1 the whole square, plus minus 10 minus 6, that is going to be minus 4 the whole square, right? Which is basically square root of 1 plus 1 plus 16, that is root 18, that is basically 3 units, right? Then you have mod QR, that is going to be square root of this what? 1 minus 4, that is minus 3 the whole square, plus 6 minus 9, that is again going to be minus 3 the whole square, plus minus 6 minus 6, that is going to be 0, right? And 0 squared is basically, this is equal to square root of 9 plus 9, that is basically 3 root 2 units, right? Now I don't need to check for PR because I know that PQR is going to be a triangle. Oh wait, no, I don't know that PQR is going to be a triangle. All right, so I have to find PR because I know that PQ is equal to QR, but I don't know that PQR forms a triangle. All right, so I'll find a mod PR, that is going to be square root of 0 minus 4, that is minus 4 the whole square, plus you have 7 minus 9, that is going to be minus 2 the whole square, plus you have minus 10 minus 6, that is going to be minus 4 the whole square, right? Which is basically square root of 16 plus 4, that is going to be root 36, that is 6 units, right? Now since you don't have like, since 6 is basically lying between your mod PQ, right, wait. Mod PQ minus mod QR is basically 0, and mod PQ plus mod QR is going to be, let this be A, right? And mod PQ plus mod QR is basically 6 root 2 units, right, which is B, right? Your mod PR is lying between A and B, right? So PQR is a triangle, right? Because your third side has to be greater than PQ minus QR, and it has to be less than PQ plus QR. And only then can it form a triangle, right? If it is greater than PQ plus QR or if it is less than PQ minus QR, that means that it does not form a triangle, but it forms something else, all right? So finally, you basically have that PQR is a triangle, and PQ mod PQ equals mod QR. Therefore, this is an isosceles triangle. All right. Therefore, you have to fact. Right. Question number 2. Do not forget that you have to prove that this is a triangle because you are just given 3 points. You are not given that they form a triangle. All right. And to prove that it's a triangle, the sufficient condition is that it follows the triangle inequalities. The two inequalities that I have just shown here. That is every side is greater than the difference between the other two sides, and that every side is going to be less than the sum of the other two sides. All right. Question number 2. You have the same 3 points. Wait a minute. It's not the same 3 points. You have point P of 0, 7, 10. Then you have point Q of minus 1, 6, and 6. Then you have point R of minus 4, 9, and 6. Right. They are the words. All right. For this, we again have to find out the distance of the 3 sides. This is one is mod PQ, which is square root of, I'm going to directly go ahead with the calculations without explaining them. This is 1 square plus 1 square minus, wait a minute, plus this is plus 10 minus 6, that is going to be 4 square, right? Which is basically 1 plus 1 plus 16, that's 18, that is 3 root 2. Then you have mod QR, which is square root of minus 1 minus 4, that is going to be 3 squared, plus 6 minus 10, that is going to be minus 3 squared, plus 0, right, which is again 3 root 2 units, right? You have PQ and QR being 3 root 2 units, and then you have mod PR being what? Mod PR being square root of 0 minus 4, that is 4 square, plus 7 minus 9, that is minus 2 square, plus 10 minus 6, that is again going to be 4 square, which is, since we have done this calculation before, this is basically 6 units, right? Now, notice that PQ, QR, and PR form a triangle because I've already shown it to you earlier. And you have PQ squared plus a mod QR square is going to be 18 plus 18, that is 36 square units, right? Which is basically equal to mod PR square, right? Since you have mod PQ square plus mod QR square is equal to mod PR square, therefore, you have the fact that PQR is a right triangle because it follows the Pythagorean theorem, right? And the Pythagorean theorem is a sufficient condition to prove that a triangle is a right angle triangle. Correct. Now going to question number 3, right, which states that you have 3 points minus 1 to 1. Then you have subpart 3, which states that you have 3 points P of minus 1 to 1. Then you have Q of 1, minus 2, 5. And then you have point R of minus 4, 9, and 6. Then you have third point R, which is 4, minus 7, 8. And the fourth point S, which is 2, minus 3, and 4. Right. You should show that these 4 form a parallelogram. To prove that it forms a parallelogram, what you have to prove is, wait a minute. You have to prove that PQ is equal to RS, right? And PS is going to be equal to QR, right? These are the 2 things you have to prove that these 4 are the vertices parallelogram, all right? This is going to be a sufficient condition. The opposite sides are equal. Alternatively, you can show that the opposite lines are going to be parallel, but yeah, anyone works, right? So we have mod PQ being again defined as square root of x1 minus x to the whole square, that is going to be minus 2 squared, plus this is going to be 2 minus 2, that is going to be 4 squared, plus 1 minus 5, that's going to be minus 4 the whole square. And this 16 plus 4, that is going to be 36, and root 36 is basically 6 units, right? Then you have mod QR, which is going to be square root of, this is what? 1 minus 4, that's going to be minus 3 squared, plus minus 2 minus 7, that is going to be 5 squared, plus 5 minus 8, that's again going to be minus 3 squared, right? Which is basically square root of 43 units, right? Because it's 25 plus 18, that's 43, right? And then you have mod RS, that is going to be what? 4 minus 2, right? This again going to be 2 square, plus this minus 7 minus 3, that is going to be minus 4 the whole square, plus you have 8 minus 4, that is going to be 4 square, which, since I've done the earlier calculation, is again 6 units, right? And you have mod PS, that is going to be square root of x1 minus x2, that is minus 1 minus 2, that's minus 3 the whole square, plus 2 minus 3, that is again going to be 5 square, plus 1 minus 4, that is again going to be minus 3 the whole square, which is basically 9 plus 25 plus 9, that is again going to be 43 units. All right. Therefore, you have the fact that mod PQ, right, is going to be equal to mod RS, right, and mod PQ, right, mod PS is equal to mod QR, right? Therefore, PQRS is a parallelogram, right? If your opposite sides are equal, then your quadrilateral is going to be a parallelogram. There's no other one. Right? It can be a rhombus, it can be a square, it can be a rectangle, but they are all parallelograms. All right. Going to question number 4. Find the equation of the set of points which are equidistant from the points 1, 2, 3, and 3, 2, minus 1. Right. Let the points P, right, let one of these points P be X, Y, Z, right? and the 2 points A and B are 1, 2, 3, and B is 3, 2, minus 1. Alright. So now you are actually asked the equation of the set of points which are equidistant to the points this and this, right? Which is basically asking for the locus of the points P, right? You are given that mod PA is basically equal to mod PB, right? On the Cartesian plane, just figure out what this equation represents, right? If you have two coordinates only, right? If you have a point P of x, y, and you are given 2 points A and B in the Cartesian plane, that's of the x and y coordinates only, right? Figure out what this locus will be, right? What the points, the set of points equidistant from 2 given points represent. Fine. All right. The answer is an ellipse, but yeah. Okay, no, the answer is not an ellipse. I figured the answer. Right. The answer is not an ellipse. The ellipse is the sum of the distances is always a fixed constant. That's an ellipse. But whatever. Yeah, you have that PA is equal to PB. So now what you can do is you can write that PA squared is going to be equal to PB squared. Right? No loss in data, nothing happens because you know that the links are going to be positive. Right? So you have PA squared is PB squared. Thus you have the fact that x minus 1 the whole square plus y minus 2 the whole square plus z minus 3 the whole square is going to be equal to x minus 1, right? X minus 3 the whole square, sorry, plus y minus 2 the whole square plus z plus 1 the whole square, right? So since you have this big run-on equation, what I'm going to do is basically spread it up, right? This basically equals x squared plus y squared plus z squared, right? Plus, wait a minute, this is not plus, this is going to be minus 2x minus 4y, wait a minute, this minus 2x plus minus 4y minus 6z plus this is 149, right? 1 plus 4 is 5, 5 plus 9 is 14 is equal to, on this side, you again have x squared plus y squared plus z squared. Then you have minus 6x minus 4y minus this is plus 2z, right? This is plus 2z, right? And you are adding 9 plus 4 plus 1, that is again going to be 14, right? 14 cancels out. X squared plus y squared plus z squared cancels out with x squared plus y squared plus z squared. And you are left with this one. This is 4x plus y and y cancels out, right? Because you have minus 4y on both sides. 6x goes here, becomes 4x. And over here, you have minus 8z, right? This minus 6z minus 2z becomes minus 8z. So wait a minute. This cancels out. And I'll just rub this off. So I have 4x minus 8z is going to be equal to 0. Or you have the fact that x is equal to 2z. Right? This is a plane, right? X minus 2z is equal to 0. This is basically a plane in space. Alright. So over here in 3-dimensional space, the set of points that is equidistant from 2 given points is going to be a plane. Right. Similarly, in 2-dimensional space, the set of points that is going to be equidistant from 2 given points is going to represent a line, a straight line. Right? It's not a circle, it's not an ellipse. I'm sorry for that. It is a straight line. Right? Last question. Find the equation of the set of points P, the sum of whose distances from A 400 and B minus 400 is equal to 10. Right? In 2-dimensional space, find out what this locus is going to represent. That is a task. Right? So you are given a point P, you are asked for a point P, let the coordinates of P be x, y, z. Right? Then you have the points A 400 and you have the points B that is minus 40. Both these points lie on the x-axis. Right? Now you are asked for the points P such that mod PA plus mod PB is going to be equal to 10. Correct? So use the, you have to use your natural skills. You have no other go, right? Figure out the fact that then mod PA is going to be equal to 10 minus mod PB, right? Or you have mod PA square is basically equal to 100 plus mod PB square minus 20 times mod PB, right? Now what you're going to do is, I'm going to substitute this PA square and this PB square. But I'm going to leave this as such because I'm not going to write down the whole root and then, basically leave the whole root aside to write it again and again and again. I'm not going to do that. All right. So I'm going to substitute mod PA. That is going to be equal to square root of, wait a minute. This is not square root because it's mod PA squared. So I'm going to basically remove the square root. And I'm going to write this as x minus 4 the whole square plus y squared plus z squared, because the other two coordinates are 0. It's basically equal to 100 plus this is x plus 4 the whole square, right? Plus y squared plus z squared minus 20 mod PB. All right. And you can bring this to the other side and write this as minus x plus 4 the whole square, right? Since you have x minus 4 the whole square over here, this basically cancels out with this and you're left with minus 16 times x, 16 into x into 4, that is basically minus 64x, right? Because 2ax is going to basically be, wait a minute, 2 into x into 4 is going to basically be 8x, and so you're going to be left with minus 16x, right? Because this is minus 8x, and here it is minus of plus 8x. That is going to be minus 8x, so you're going to be left with minus 16x. Right, and this is going to basically be equal to 100 plus y squared plus z squared, which cancels out over here, and you're left with minus 16x is going to be equal to 100 minus 20 times mod PB. All right. Therefore, bring this here, You're going to have 16x plus 100 divided by 20 is going to be equal to mod PB. Right. Square it. You're going to get, wait a minute. First, I'll just drop a 4, right? You're going to be left with 4 over here, 5 over here, and you're going to be left with 25 over here, right? So squaring on both sides, right? I get divided by 25. Over in the numerator, I'm going to get 16x squared plus this is 425, that's 100 plus 200x plus 25 squared is 625, right? And it's divided by 5 is equal to your mod PV square, that is going to be x squared plus 8x plus 16 plus y squared plus z squared, right? So just, spreading all this, you get 16 by 25x squared plus 8x plus 25, which is equal to x squared plus 8x plus 16 plus y squared plus z squared, right? This 8x cancels out, right? This 16 goes over here and you get a remainder of 9, right? This x square, this is 16 by 25x square, it cuts over here and you are left with 9 by 25x square, right? This is basically 9 by 25x square. So therefore, you are left with basically 9 is equal to 9 by 25x square plus y square plus z square, right? Or you can basically rewrite this as 1 is equal to, or wait a minute, instead of 1 is equal to, I'll rewrite this as x squared by 25 plus y squared by 9 plus z squared by 9 is going to be equal to 1, right? You may, search Wikipedia for any equations of this form, right? You're going to get that this basically determines an ellipse or something of the sort, right? In the two-dimensional space, this is going to represent an ellipse, right? It is not a circle, but it's an ellipse. All right. This is basically the locus of P, right? Remember this word locus? You're going to be dealing with it in later chapters. The locus is basically the path of the points, path of the point P traced when you vary x, y, and z. Right. Right. Finally, you are left with the miscellaneous exercises. Right. Look at these examples because they are actually pretty important, and they are also quite a bit more than what you have learned in the output exercises. All right. They are not of very different or very difficult levels. They are pretty decent in difficulty, but you can look at them to get to know the different types of questions that we asked in the exercise. All right. So we go into the miscellaneous exercises. MIC, right? We have again 4 questions. Very short chapter over here. So we have the first question: 3 vertices of a parallelogram ABCD, right? 3 vertices of a parallelogram ABCD are A of 3 minus 1 2. Yeah. 3 minus 1 2. 1 to 4. A of 3 minus 1 2. B of 1 2 minus 4. And C of minus 1 1 2. Find the coordinates of the 4 quadrants. Right? Now remember that for a parallelogram, right, 2 sides are going to be parallel. Right? Each alternate side is going to be parallel to each other and equal. Right? It's going to be parallel and it's going to be. So if you have here over here A of 3 minus 1 and 2, then you have B of 1 2 minus 4. Then you have C of minus 1 1 and 2. Right. The way you can find out the 4th coordinate is basically by by determining the lines AB and AB, translating it to the point C, and finding out the point D at a distance of AB from C. Or you can basically be a little more intelligent and make use of the fact that the diagonals of a parallelogram basically bisect each other, right? If this is the midpoint M, you basically have this equal to this and this equal to this, right? So therefore, your midpoint M is going to be the midpoint for both the diagonals AC and the diagonals B, right? So you have the point of M being, let this be X, Y, Z, right? X, Y, Z, or X1, Y1, Z1. Don't get confused with the normal X, Y, Z for a locus. All right, let this be M of X1, Y1, Z1. Then you have the fact that M is the midpoint of AC, right? Midpoint of AC. Wait a minute. Here, the distance, wait a minute. Why isn't the midpoint formula there over here? Weird. That's actually very weird. Okay, fine. Your midpoint formula in the 3 coordinate system is basically an extension of the 2 coordinate system, where instead of this being x1 plus x2 by 2, y1 plus y2 by 2, you have x1 plus x2 by 2, y1 plus y2 by 2, and z1 plus z2 by 2. Right? You just are going to introduce a new constraint in z. Right? You're not going to drastically change the formula at all. All right. So the midpoint of AC is basically you have this is what 3 minus 1 by 2, comma, this is going to be minus 1 minus 1 plus 1 divided by 2, comma, this is going to be 2 plus 2 divided by 2, right? Which is basically equivalent to, this is 2 by 2, that is 1, this is 0, and this is going to be 2 plus 4 by 2, that is 2, right? This is going to be the coordinates of M, right? This is basically x1, y1, and z1, right? That is equivalent to 1, 0, right? But this is also the midpoint. Wait a minute. This is also the midpoint of B2. Therefore, 102 is basically equivalent to The point let D be x2 or instead of 2, I'll write this as xd, yd, zd. Alright. So there's no confusion between x1, y1, z1 and x2, y2, z2 or whatever. And I'm going to write this as xd, yd, z2 directly. Right. So we have the midpoint m being xd plus 1 by 2. So you have the midpoint m, that is 102, is equal to xd plus 1 divided by 2, comma, yd plus 2 divided by 2, comma, zd minus 4 divided by 2. Right. Since this is equal to 1, right, xd plus 1 is equal to 2. That is, xd is going to be equal to 1. Right. Then you have yd plus 2 is going to be equal to 0, or yd is equal to minus 2. Similarly, you have zd minus 4 is going to be equal to 4, or zd is going to be equal to 8. Right. Therefore, the coordinates of the point D are 1, minus 2, and 8. And that is how you solve the first list. Right. Instead of going too far, finding out the lines, finding out the slopes, and then figuring out the distance, and then figuring out the point at a distance of D from a point on the line, basically that is a very, very long process. Instead of doing that, you can basically take the midpoint of the two diagonals and then say that since the two diagonals are going to bisect each other, the midpoints of the two diagonals are going to be the same point, that is M. Find the coordinates of M, and from that find the coordinates. Right? Let's resolve the first case. And it's actually very weird that you don't have the midpoint of the section formula in the coordinate system. Very weird for that. But yeah, fine. Question number 2. Find the lengths of the medians of the triangle with vertices A006, B040, and C600. Right? A of 006, B of 040, and C of 60 and 0. Right? So basically, you have a coordinate you have a triangle which lies on the 3 coordinate axes. Right? This is basically going to be tilted somewhat like this. Right? It's going to be a tilted triangle, or lying with its base and the vertex or the 3 coordinate axes. Right? So if we just if I just directly look at the triangle, right? You have A, you have B, you have C, right? And you have a point D that is going to be the midpoint of BC. You are going to have E, which is going to be the midpoint of AB, and you are going to have F, which is going to be the midpoint of AC. Right? Or actually, better yet, this is going to be E, and this is going to be F. Right? Because AD, BE, and CF are going to be the 3 medians. All right. So they also made at a single point. They don't form this kind of triangle in the middle. Excuse me, shoddy drawing. All right. So we can basically find out the coordinates of D. That is the midpoint of BC. Right. This is basically the midpoint of BC. Since you have the coordinates of BC, you can find the coordinates of D as B plus C by 2. That is going to be 3, comma. This is 4 plus 0 by 2. That is going to be 2. And this is 0. Right? Similarly, E can be the midpoint of AC. That is going to be 3, comma, 0, comma, 3. Right? Because it is 6 plus 0 or 0 plus 6 by 2. That is 3. 0 plus 0, that is 0. And 6 plus 0 by 2, that is again, that is again 3. Right? And finally, F can be represented in the same form as the midpoint of AB. That is going to be 0, comma, 2, comma, 3. Right? Thus, you can find the midpoint. You can find the lengths of the medians. That is length of AD, that is represented by the distance formula, square root of dA. There will be 0 minus 3, that is minus 3 the whole square, plus minus 2 the whole square, plus 3 minus 0, that is 3 the whole square. Right? This is basically 9 plus 9 plus 4, that is square root 22 units. Right? Similarly, mod BE is going to be square root of this is what 040 and 303, right? So you are going to have 3 square plus 2 square plus 3 square units. That is again going to be root 22 units, right? This is 006. So this is minus 3, minus 2, and this is not 3, this is 6. Very sorry for that, right? So instead of 22, we're going to have, this is 9 plus 4 plus 36. That is, this is going to be 40, root 49 units. That is going to be 7 units, right? Similarly over here, we're going to have 3 square plus 4 minus 0, that is going to be 4 square, and then 3 square. And not, there's not 2 square, right? So you're going to have 3 square plus 4 square plus 3 square. That is 9 plus 9 plus 16. That is 18 plus 16. That is root of 34 units and not 22 units. I'll just, this is 34 units. And finally, you have the median CF. That is again going to be the root of this what? 6 minus 0 the whole square. That is going to be 6 square. 6 square. Plus this is what? 2, this is 0 minus 2. It's going to be minus 2 the whole square or 2 square. Plus minus 3 the whole square. Right? I'll actually have to write this as minus 3 the whole square and minus 3 square because I've been following that convention for so long. Right? So this calculation we have already carried out. This 36 plus 4 plus 9, that is going to be 49. That is going to be 7 units. Right. So we have found the lengths of the three medians. AD, which is 7, BE, which is 34, and CF, which is again 7 units. Right. With that, we complete question number 2. Question number 2. The origin is the center of the triangle PQR with vertices P of 2A, 26. Wait a minute. What is this P of 2A, comma 2, comma 6. We have the vertex Q, which is minus 4, 3B, minus 10. And then you have the vertex R, which is 8, 14, and 2C. Right? You have to find ABC. Right? We are also given that the center G is at the origin 0, 0, 0. Right? G is usually the letter we denote the centroid with. So do not get confused when I'm writing G instead of O over. Right? We know that the centroid G is basically represented by x1 plus x2 plus x3 divided by 3, comma y1 plus y2 plus y3 divided by 3, comma z1 plus z2 plus z3 by 3. Right? So we have these 3 points. We have the formula for the centroid like this, right? Which comes from the fact that the centroid is a meeting point of the 3 medians, right? So geometrically, you get this equation, right? For the proof, you can actually see any see a Wikipedia page or I don't know if it's given in the inside book. I'm not sure for that. All right. That notwithstanding. Right, let us proceed. Right, so since we have this, right, and next one, this basically follows if you have your 3 vertices of the triangle being, wait a minute, this x1, y1, z1, right, b of x2, y2, z2, and c of x3, y3, z3. Right, this is the centroid. Centroid for triangle ABC. Centroid of triangle, right? This is G, which is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, z1 plus z2 plus z3 by 3. All right. So since you have this, right, and you have PQR as represented over here, I can directly write this equation and say that the point 0, 0, 0, right, I just write this comma, is basically equivalent to the point 2a minus 4 plus 8 divided by 3, 2a minus 4 plus 8 by 3, comma, you have 2 plus 3b plus 14 by 3, that is 2 plus 3b plus 14 by 3, comma, and you have 6 minus 10 plus 2c by 3, minus 10 plus 2c divided by 3, right? Since this one is equivalent to this, so basically you have the fact that 0 is equal to 2a minus 4 plus 8 divided by 3, which means that 2a plus 4 is basically equal to 0, which implies that a is equal to minus 2, right? And this is number 1. Number 2 is basically 0 is equal to 2 plus 3b plus 14 by 3, right? 2 plus 3b plus 14 divided by 3, which implies that 3b plus 16 is equal to 0, which implies that b is basically equal to minus 16 divided by 3, right? And you have basically that 6 minus 10 plus 2c by 3 is equal to 0, right? You have the last equation, that is 0 is equal to 6 minus 10 plus 2c divided by 3, which implies 2c minus 4 is going to be equal to 0, which implies that c is equal to 2, right? Therefore, you have found the value of a, you found the value of b, you have found the value of c, and that's what's asked, right? A is minus 2, b is minus 16 by 3, and c is plus 2, right? Finally, the last question of this chapter, right? You have 2 points a and b, right? A is the point 3, 4, 5, and b is the point minus 1, 3, minus 7, right? Just a sec. Let's draw this as a bigger line. 5, minus 1, 3, minus 7. Find the equation of the set of points p such that pa squared plus pb squared is k squared, where k is a constant. Try to figure out what this locus is going to be if we are going to do this on the Cartesian plane instead of three-dimensional space, right? For every locus question, you can make it an exercise to do that. Then you get accustomed to locus questions, and then you will find a set of questions in JEE Mains or JEE Mains to be easy, right? If you're going to attend JEE, if you're not going to attend JEE Mains, then I don't think there's a need to it, right? So yeah, what will it be? Let the point P be the point P of X, Y, Z. All right. Now we have P A squared or mod P A squared, as I better like to represent it, plus mod PB squared is going to be equal to K squared, where K is constant, right? Which means that since P A squared is, I can basically represent this in the distance formula form, right? P A squared is going to basically be X minus 3 the whole square plus y minus 4 the whole square plus z minus 5 the whole square, right? Plus PB is going to be x plus 1 the whole square plus y minus 3 the whole square plus z plus 7 the whole square, right? That is going to be equal to k square, where k is constant, right? K is a constant. K is constant. Right. So then just directly, separating this out, I can basically state that x square, this is x square minus 6. I just, separate out all these square terms over here. This is x square plus y square plus z square plus x square plus y square plus z square. Right, because we have two x minus something and x plus something terms. We have a y minus 4 and a y minus 3 square terms. And you have a z minus 5 square and a z plus 7 square term. So each of these is going to contribute one x square or one y square or one z square respectively. So we have two sets of x square plus y square plus z square, right? This minus, this is going to be 6x minus 8y minus 10z, right? Plus 2x minus 6y plus 14z is going to be, this plus, this is going to be what? 9 plus 16 plus 25, that is going to be 50. And this is 1 plus 9, that is 10, plus 49, right? That is 59. So since this is 50 and this is 59, I can directly write this as plus 109 is going to be equal to k squared, right? Then basically, collating all like terms, I can write this as 2x squared plus 2y squared plus 2z squared, right? Minus, this is 6 plus 2x, that is going to be minus 6 plus 2, that is going to be minus 4x, right? This is minus 8 minus 6, that is going to be minus 14y And this is going to be minus 10 plus 14, that is going to be plus 4z, right? This is 4z plus 109 is going to be equal to k squared, right? This is basically a required equation, right? This is going to be one of the forms of your locus, all right? This basically is equal to, this is equivalent to x squared plus y squared plus z squared minus 2x plus 7y minus plus 2z, right? Is equal to k squared minus 109 divided by 2, right? And that is one of the other forms of the required locus. Some other forms you can try to represent it is as a standard sphere, like x minus 1 the whole square plus y plus 7 by 2 the whole square plus z plus 1 the whole square minus this what 1 plus 1, that is 2, 2 plus 49 by 4, that is 53 by 4, right? So this can be 53 by 4 minus 53 by 4 is going to be equal to k square minus 109 divided by 2, right? Basically take this to the other side. So you can basically write this as what? So this will be 2k square minus 218, that is this will be 165, right? Yeah, this is going to be minus 165 divided by 4. Something like this. You can also write this in this form, right? So you'll have over here x minus 1 the whole square plus y plus 7 by 2 the whole square plus z plus 1 the whole square is going to be equal to this, right? This form is also another form of your locus, right? This is going to be the standard equation of a sphere, right? This is your this is going to be the center of the sphere, and this is going to be the radius of the sphere, right? Depending and it is only a sphere if and only if 2k square is going to be greater than 165. Else it's not going to be a sphere because it's going to have negative radius, which is not possible, right? So this is this form or this form, right? Wait a minute. Either this form or this form or this form. Any one of these three forms are okay, right? You can write this in any form, provided that you don't make a mistake in the sign, you don't make a mistake in the right hand side, you don't make a mistake anywhere else. All right. So this is going to be the required locus, and this is basically a sphere. All right, guys. With that, we finish the chapter Introduction to Three-Dimensional Geometry. Thank you for listening. Hope you have a nice day.